Hello, this is the School of Engineering PhD information session. My name's Peter Gammon and I'm the Director of Graduate Studies for the School of Engineering. Usually every year we hold these sessions in A401 with a lunch, but some change is good, and hopefully this video will now reach more of you than potentially the lunch sessions did in the past. So um, please continue to watch this video if you're interested in the prospect of doing a PhD in the forthcoming year. Hopefully there's a lot of information here about how you can apply for PhDs, whether a PhD is right for you, and we'll be hearing from a current PhD student to get their perspective also. So here's what I'll be running through. What is a PhD? Why do a PhD and why not do a PhD? PhD funding, the sources thereof. Meet an engineering PhD student, as I mentioned before. One of our current PhD students will talk through their experience. And then I'll have some slides at the end, which I will put up for you to read through about different PhD research areas available within the School of Engineering. So first of all, let's start at the very basics, which is what is a PhD? A PhD is 3 to 3.5 years of postgraduate study following either a bachelor's or a master's level, so after your undergraduate course. The requirement is to produce a thesis at the end of that time, which offers a significant new contribution to knowledge in the subject that you are choosing. People often measure that in terms of journal papers or conference papers that you've written, but there needs to be some new contribution there to a field. A PhD is a doctorate and leads to you being able to use the term doctor or put PhD after your name. And you might hear it being referred to as a Doctor of Philosophy. Well, all PhDs are. That's what PhD stands for. So you end up with a PhD, a Doctor of Philosophy in engineering of whichever flavour. Day-to-day work is research, but tasks around that can include teaching, skills, a lot of technical work that you might need to be able to do your research also. The onus very much on a PhD is self-driven, self-motivated research. There is not, gone would be the times of you having assignments and a very structured, rigid process to be going through to be completing your course as you would have done in your undergraduate degrees. And you can liken your PhD much more to your third year or fourth year projects where you are driving the deliverables yourself with a coach or a mentor, which is your PhD supervisor, rather than a specific teacher as such. So what does a PhD in engineering entail? And of course it varies. And this slide that I'm going to go through here is a pictorial summary of my own experience from 10 years ago. So, but each PhD is entirely individual, and you might on average be working 35 to 40 hours a week, much more in some places and very occasionally less, but hopefully not too much less than that. And I would say that of my experience, about 30% of that time was practical in a lab, in a clean room in my experience. There was a lot of reading of literature. There was simulation tasks. I was probably quite a lot a technician because I was fixing machines and trying to get things working in a timely fashion. I did a little bit of teaching, lab demonstration, a little bit of lecturing, and some writing up of my results. So that's writing up for papers, reports, and of course the whacking great thesis at the end of it. So why should you do a PhD? Well, notice reasons 1 and 2 there. You should be doing a PhD primarily and secondarily because you are interested in the subject. And if you are not interested in the subject, it's going to be a 3-year slog. So that has to be your primary motivation, that you have a passion, an interest, a drive for whatever reason to conduct research in this area. If you don't have that, all the other reasons really don't amount to enough usually to justify wanting to do a PhD. So the other considerations that you might think of, because you might be really passionate in a subject and think, well, in that case, I'm passionate in a subject, I'll go and get a job in that area, which is a perfectly valid way of going too. But the other reasons you might want to pursue a PhD instead is because you enjoy the act of research. So the freedom that comes with research to look into a problem because a problem comes up, to solve something, an issue. You might be primarily focused on one topic, but with a PhD, unlike in a job where a job you might be primarily motivated by getting a product out or a project timeline, and that will be the chief motivator. Here, your chief motivator is really information. So if you want to spend 3 months going down a side path to find out why that result you got was not what you expected, then that's perfectly valid in a PhD, and that's the kind of freedom that you get in a research environment. Why else? You might want to be making a contribution. You might want to be making new findings in that field that you're passionate about. There might be motivations to access different types of jobs later on. You might be interested in going into academia, or you might be interested in going into research-based jobs in industry where there is a prerequisite of having a PhD quite often. Another motivation finally there is the transferable skills you will develop in academic writing, in communication, in presentation, in independent thought and critical problem solving skills, analysis. All of these things are skills that you will develop in a PhD, which will serve you well, whatever you did after it. Reasons not to do a PhD. PhD is certainly not something to do if you're primarily motivated by salary. If you're wanting to go very quickly up a chain and earn lots of money fast, because although you might have access to different types of jobs, they're not necessarily the types of jobs that will immediately get you rich, I'm afraid. Because I want to extend my stay at the university, I've heard it a few times in the past. It's not a good reason, and it often ends in tears, because that being a chief motivator doesn't link in with what I said first and foremost, which is you've got to be passionate in the field. Well, maybe the two can coexist, but if your primary reason is because you want to extend your stay at university, then please consider something else. Because my supervisor tells me how wonderful the subject is. Make sure you do your own audit on it, of course. If you're being sold a dream by an academic, do your own reading around it and make sure it's something that you're absolutely passionate about as well. Because it sounds easier than getting a job. I refer you back to because I want to extend my stay at university. They parallel. And that also goes into because I don't know what else to do. They're poor reasons to do a PhD, and often will end up in wasted time rather than productive time. 3 to 4 years is a big time commitment, and don't take the decision lightly. Take time to reflect. All the deadlines that I will show you later, all are within 2 or 3 months' time. So take time to consider that it's exactly what you want to do. How do you apply for a PhD? Well, let's just talk about the mechanics of this first before we talk about funding. Let's separate out the two. So to be able to qualify to do a PhD, the minimum standard is to have a 2:1 undergraduate degree in a relevant subject. So you can start doing a PhD in engineering if you have a 2:1 bachelor's award in physics, chemistry, engineering, etc. MScs and MEngers are good, relevant, recommended, but not essential. If you are certain, as a third-year student, for example, that you have decided which route you want to go to, then there is no requirement that you complete the MEng or complete an MSc before going on to a PhD. A master's level course, an M level course, is incredibly helpful where you have not yet made up your mind, where at bachelor's level you have barely scratched the surface of the field that you're in, be it mechanical engineering, physics, electrical engineering, and you need more information in each of these specific areas before you can make any decisions about what you want to go on to do. So it might be that you need that extra year of experience and understanding of a field before you feel ready to commit to a PhD. If you are not already in the UK, you would need English proven to the level of IELTS level 6.5. Most often when you're applying for a PhD, you'll need a research proposal, and that's something that you can develop with a prospective PhD supervisor and submit as you're applying. Now, if you're applying for a specific scheme, that will be essential. If you're responding to an advert in a very specific area, then it won't be requirement. It will be you are applying to go onto a set project which has its own proposal as such, so you wouldn't need it. But certainly if you're doing a scholarship or something where it's an open competition, you will need to show you've got your own set ideas. There's a link there for how to apply, and I will how to apply for a PhD at Warwick, and I will send these slides around with this video. Of course, you will need to discuss this with a member of staff first. So the first port of call, if you're interested in a specific subject area, is to go and talk to academics in that area. Next, let's look at how to finance a PhD, and we'll start off with the bare facts here, because of course you can finance yourself through a PhD if you wish to. And if you're a home student, that would mean that you would have to be finding £4,400 a year, and typically that's for 3.5 years. International students, which unfortunately includes EU students from 21-22, are subject to fees of £24,000 a year, again for 3 years of 3 years of fees. Many students will want to self-finance their way through, and that's absolutely fine. But there are avenues of funding that are available, which I'll go through next. And most scholarships will provide a stipend, living costs of £15,000 a year, which gives you some kind of idea, if you are self-funding, how much you'd need to be finding to on top of the fees to in terms of living expenses for that for the time period of a PhD. So here's some places where you can get funding. And the first place, if you are a home student, a UK student, is our own School of Engineering PhD scholarship scheme. And in this academic year, 2020, 2021, we will have up to 4 studentships to give away for home students. That includes full funding and fees for 3.5 years, and it also includes a research fund of about £3,500, I think it is, to carry out your research. You must apply with an engineering academic. You'll require a CV, a research proposal, and to fill out the application form. The start date would be October 2021. There's a link there to have a look at the full details, and the deadline for this is the end of March 21. For international EU students from 21-22, your first place you might want to look at is the Chancellor's International Scholarships. Chancellor's International Scholarships are run by Warwick University, and there are 42 available across the whole university. So in engineering, our aim would be trying to get 2 or 3 of those across the whole from that pot. So you can see immediately that this is a tough ask. This is a competitive scheme. But what it is full funding for an international student, both fees and a stipend for 3.5 years. Again, they must apply with an academic, and they would need to be producing a very good research proposal along with the application form. You'd be required to make a general application first, and then you would be applying to the scheme. So first of all, you apply for a PhD, then you apply for the scholarship. Again, the start date's October 21, so for the 21-22 year, and the deadline is tight. It's the 21st of January, so you would need to be getting onto that soon. I must reiterate this scheme is ultra competitive. So I'm afraid, to be perfectly blunt, if you are not expecting to get a first class honours, then it might not be the scheme for you. These scholarships are awarded to some extremely good candidates every single year. So please do bear that in mind. The next scheme is the Chinese Scholarship Scheme, which I think most Chinese nationals will be aware of. But at Warwick, we have our own competition, and this is how Warwick University interacts with the Chinese Scholarship Council. We do not have the ability to react to single individual ad hoc applications. So anybody who is interested in taking up CSC funding must come through this route. So the university is prepared to provide funding for 25 CSC studentships. And engineering is very fortunately a priority in that. And so we do very well out of this competition, and we will get 5 to 8 successful studentships through this most years. So we have a good success rate with this. As is normal with CSC, applicants are obliged to return to China after graduation, or I believe they have to pay the money back. In this scheme, as opposed to most CSC schemes, you must apply to Warwick first, be accepted by Warwick first, and Warwick would then recommend you to the CSC Council, the Chinese Scholarship Council, second. That is the opposite way around to how the CSC typically operates. Again, the deadline is the 21st of January. Again, the start date would be October 2021. So those are the very specific schemes. There are always individual scholarships available, and the best place to look for those is often online at things like findaphd.com. There's a few other places. And those will be scholarship schemes, scholarships or studentships that are attached to very specific research project. So you would be applying not to do a PhD in any area, but in a very specific attached to a very specific project. Um, Typically, they would be as long as normal, 3 to 3.5 years. And we hold our own list at this link here, that you can follow to see what we have within the school right now. Feel free to talk to the academic who's listed. They'll be able to tell you more. That would be a wise place to start if you find anything you're interested in. Other sources of funding. There is a sanctuary scholarship for those people who might consider themselves refugee status or something similar to that. There are often national government scholarships if from very specific countries. Indonesia, Malaysia's quite often got their own scholarships. And within other universities, other departments, as I say, you can find a full list at jobs.ac.uk or find a PhD. Just to add to the previous opportunities, we have 2 centres for doctoral training within the school. These are programmes of PhD studentships within a very specific area. And the first of these is within it's called the Future Mobility Technologies CDT, which sits across both engineering and WMG with 2 streams. The first stream, which sits within engineering, is to do with the development of power electronic devices, the development of those devices, the testing of them, and using them in circuits, the packaging of devices, right the way across the value chain from materials up to circuits. So if you want to find out more, follow the link, and they will be looking for probably 4 students in 21-22. For information, the second stream in the FMT CDT is to do with connected systems. So it's the communications on board future vehicles. So again, follow the link and you'll find out more information there. The second Centre for Doctoral Training we have is called the HETSIS CDT, and this concerns mathematical modelling, predictive modelling across disciplines. So it promotes mathematical skills, flexible thinking, and complex physical problems across multiple different areas. So they have some projects in electronic devices, pharmaceuticals, superalloys, microfluidics, laser-driven fusion. You can see there's a range of different areas in which the commonality there is the way in which they model the systems from the small scale up to the very large scale. So on the right you can see the different levels of modeling that they'd be interested in. So from the atomistic level all the way up to the macro scale. These are 4-year projects. You would be working as a cohort again to start off with before working in your own specific areas. Follow the links for more details, or do get in contact with either James or Julie. So what should you be doing next? Primarily, the first thing you ought to be doing if you want to do a PhD is to be finding an academic in the specific area you are interested in. Now, you may have a good idea of the academics within the School of Engineering from your undergraduate course, but there's every likelihood that there are a few academics out there that you haven't met. So I would encourage you to be having a look on the the School of Engineering web pages and seeing what research areas are available and the specific people that are in that area. And I would encourage you to talk to not only the person that taught you at undergraduate level, but potentially 2 or 3 others in that area, so that you get an idea of the research that's going on in that field in the department. If you need any guidance beyond the website there, you can email me and I might be able to put you in touch with an academic in that area. Then I would consider choosing a scholarship competition or two or three within the school, without the university if necessary, and apply to these different schemes. Work on an application, take your time over producing a good CV and a research proposal if it is required for the scheme you're applying for, and if necessary, run those research proposals by the academic in that area. If you're applying to do a PhD with somebody, then you might want to run their research proposal past them before applying, and that's certainly true if you're applying for the scholarships. So ask for help. Ask for help if you need it from me also in any of the process. And remember to submit your PhD application well in time. And if you're applying for specific scholarships, you may need an offer before you can apply for the scholarship. So it might be that you need to get your PhD application done sooner so that you can apply for the funding by the deadline. Next, I will introduce Guy Baker. He is a current PhD student in my research group, in the silicon carbide power devices group, and he's going to talk you through what his PhD has consisted of so far, his experiences, and how he has found the whole thing.
Hi, my name is Guy Baker and I'm a fourth year PhD student here at Warwick. I'm based in the Power Electronics group and Peter Gammon is my supervisor. In this presentation, I'm going to talk to you about what a PhD student does and demystify that world of research for you a little bit from a student's perspective. So what do PhD students do? The learning and the research that we do is quite different when compared to undergraduate studies. You're given much more responsibility and ultimately you're the captain of your own ship. PhDs can be theoretical, computational, experimental, and that will vary depending very much upon your PhD project. Many of you will be doing your third and fourth year projects, and if you've enjoyed this dissertation style of study and you've enjoyed this independent learning, then I would highly recommend considering what a PhD is. The relationship with your supervisor is really important. So if you are considering doing PhD work, I'd recommend meeting them before you start. How are you assessed throughout your PhD? One of the exciting things for me when I started my PhD was the prospect of no assignments. There are checkpoints that you need to hit along the way, but ultimately you achieve your PhD through publishing work and eventually writing this all up in a lab report or a thesis. And you're given a lot of time to do this. You're given 3 or 4 years. So it's a process of learning and critical thinking. So how do we get from me to Dr. Me? This is a process that would typically take 3 or 4 years, depending on how much funding you have. And this is a really long time. So it's important to have the right motivation and to approach your PhD for the right reasons. As I mentioned before, it's a process of independent study similar to your dissertation. It's a process of learning and critical thinking. And ultimately you get to challenge something and research something that no one's done before. And this is really exciting because it allows you to contribute to your field and to human knowledge, which is a really important achievement. So how do you do this? How does your PhD look? There's no such thing as an average PhD working week. And I think this is one of the perks of doing a PhD. It's incredibly flexible, not only in the nature of the work, but where, when, and how you do this. You might be reading up on literature. You might be proving some of your ideas computationally. You might be proving some of these ideas experimentally. And this is one of the really nice things about doing a PhD, is that it's incredibly varied and it's incredibly stimulating, and you're given a level of freedom that I don't think you have with many other jobs. And naturally, with this, the time that you spend on your PhD can be incredibly varied depending on what you need to do, and how you can do that. And this comes back to this level of responsibility, and ultimately this comes down to you, and that's why it's important to have the correct motivation, because it's a long time to stick with something, but it's incredibly rewarding. So feeding back onto the theme of responsibility, ultimately this comes down to the correct motivation and having a good relationship with not only yourself but your supervisor. Working independently ultimately comes down to trust. Going back to your third and fourth year projects, if you've enjoyed the independent nature of those works and you've enjoyed sort of taking hold of those projects, then I definitely recommend looking into a PhD. So what else do PhD students do? As a PhD student, you're still a student at the university, and you're given a huge scope of extracurricular activities you can do. The department and the university offer language courses and teaching qualifications. You're given the opportunity to teach some of the undergraduate labs that you're all doing at the moment as well. Furthermore, there's a lot of PhD and postgraduate facilities and events put on throughout the year, which is a really great way of meeting other PhD students. You're also given the opportunity to present your work on an international scale, and travel to conferences all over the world. Peter, myself, and a few other members of our research group went to Japan in September, and that was a really great opportunity that we had. You also are given the opportunity to collaborate with other universities, and depending on who your funding body is split some of your time between universities and engage with other PhD students and universities, again on a global scale. And like I've already said, you're still a student at the university. You can still attend and partake in the sports clubs and the societies that the university offers. And there's actually a huge postgraduate cohort at Warwick. I'm part of the rock climbing club here at Warwick, and there's a group of us that regularly climb together as postgraduates. And again, this now comes back to this level of responsibility and independent working. You can work and you can partake in that extracurricular all day if you want, 24 hours a day. But it's important to achieve that work-life balance. The PhD can be incredibly rewarding, but it's about taking that balance between the independent study that you have, and it's very easy to get fixated on that, and balancing that with the fantastic opportunities that the university can offer you. The PhD is a really rewarding opportunity, and I definitely recommend taking that opportunity if you have it. It gives you the opportunity to critically think, to learn, to question, and to tackle problems that haven't been faced before. It's a really amazing experience, designing, creating your first experiment, trawling through the data and time in the lab, and then writing that up in a lab report and sort of a paper, and presenting that work to other people who are equally interested on a global scale.
Thanks, Guy. That's absolutely brilliant, and I'm happy that you managed to go over some of the points that I'd already mentioned as well. That's reassuring. Thanks again, Guy. Finally, I have some slides here about what research is conducted within the School of Engineering, and I will talk you through these 4 areas to start off with. So you'll be familiar with some of this, and certainly you'll be familiar with the idea of the 4 streams within the School of Engineering. So at first we've got the Systems and Information Engineering stream, which covers biomedical and biological systems, information engineering, and systems modeling and control. Next, we've got the Mechanical and Process Engineering stream, and that covers a quite diverse range of different things, from pure mechanical engineering to things like chemical engineering. There's some materials engineering in there as well, solar cells, and sustainable thermal energy technology. So that's the heat pumps and solar cells side of it as well. And there's the fluid dynamics and multi-scale modeling. There's electrical and electronic engineering, and that breaks down into 3 areas, but those areas have sub areas as well, as usual. Connected systems is our communications side, and we've got multiple academics working on communications of one sort or another. Electrical power, which is my own area, and that spreads from materials all the way up to making devices, to putting them in circuits, and looking at applications of power systems. Sensors and devices, as it says, the creation of sensors, that could be at the semiconductor level, that could be the chip level, systems on a chip. We've got in that area the electronic nose work. Civil engineering, which consists broadly of ground engineering, structural engineering, and water engineering, with the many different subjects that cascade down from those 3. So do go and find out more information from each of those where you're interested at the link. What follows now is some slides that my colleagues have put together in the past. I am going to just allow the presentation to just roll through these. I'm not going to try and speak to other people's research areas, even my own, which comes up first. I'm just going to let these roll so that you have the information that's there. These were put together 1 or 2 years ago, so some of the information might be out of date, but there's information there for you to start investigations with some of these people. So I will just let these go. Please pause the video if there are slides that you are interested in.